I've been getting a lot of requests to make a video giving the instructions on a process called completing the square. And completing the square can be used for a couple of different purposes, but the one I want to focus on today is when you're asked to complete the square to change a quadratic equation from standard form to vertex form. This is an example of a quadratic equation that's in standard form. Notice there's no parentheses that are in this right side of the equation. And the goal is to change it so that it does have parentheses on the right side of the equation and that the term inside the parentheses is a binomial that's squared. And that's what's referred to as vertex form. In order to do this, we're going to have to do some algebraic manipulations on the equation. And that starts off by focusing on the constant. Now, constant is the number that doesn't have a variable that's multiplied to it. In this case, the constant's 50. And we don't want the 50 to be on the side of the equation with the x's just because it kind of gets in the way. So I'm just going to do a simple algebraic process here. I'm going to subtract 50 on both sides of the equation. And what's going to happen is I'm going to have that 50 now is going to be on the left side of the equation. It turns into f of x minus 50 equals negative x squared plus 10x. And that 50 that was on the right side of the equation has now canceled out, so it's gone. Next thing we want to do is we want to look at the squared variable. In this case, it's x squared, and we notice that it's got a -1 as the coefficient. That's going to get in the way of our process. So what we want to do is we want to factor that -1 out of there, and it's going to change it so that it puts the -1 in front, but it's going to change both of the terms inside the parentheses to their opposite signs. So now we have this new equation here with the -1 that's been factored out of the x terms. And next thing we're going to do is we're actually going to do the part where we're going to complete the square. So this is called completing the square because we're looking at this equation as if it's missing something. It needs something to make it a factorable equation, and we can get a squared binomial out of it. So to complete the square, we're going to put a blank on the left side of the equation and a blank on the right side of the equation, and they're going to be added into both sides of that equation. So you see this blank here and a blank right here. There is something that you have to be very conscious of, though. This second blank, on the one on the right side, it does have the -1 that is going to be affecting it. So this -1 will get distributed to all three terms in the right side of the equation. So we have to fix that. When we put the blank on the left side of the equation, we need to copy that -1 to that blank that's on the left side of the equation. And now we can start talking about, well, what's going to go in the blanks? Remember, properties of equality say that whatever you do to one side of the equation, you have to do to the other. So that's why we're doing like this, where we have to do it on both sides. We have to do it on the left and on the right. And we're going to come up with this sort of like magic number that's going to make us have an equation that we can factor into a binomial squared. So the magic number comes from looking at this coefficient of the x term. It's a -10. You take that number and divide it by 2 and then square it. So -10 divided by 2, well, that's -5, and -5 squared means -5 times -5. That gives us 25. That's what's going to go into our blanks. So this first blank is going to have a 25, the second blank is going to have a 25. And now we're just going to simplify. On the left side of the equation, we're going to do this -50 plus -1 times 25. And on the right side of the equation, we're going to factor this trinomial that's now in the parentheses. And because we picked this perfect magic number 25, we're going to be able to factor it into matching binomials. So it turns into this expression up here, or this equation up here. F of x minus 75. We got the 75 from doing -50 plus -1 times 25. And this trinomial, x squared minus 10x plus 25, becomes x minus 5, x minus 5. If you don't understand where that factored binomial come from, those two factored binomials come from, I do have other videos that talk about how to factor trinomials, and that'll go more into detail about how I got these two sets of parentheses. Now that we've got these little twin binomials here, x minus 5, we're going to rewrite this as a squared binomial. So notice the left side doesn't change, it's just f of x minus 75. But on the right side, we have negative 1 times x minus 5 squared. And we're already a little bit closer to having that form, the vertex form that we wanted. The only thing left to do now is I don't want to have this minus 75 on the left side of the equation. So I'm going to add 75 to both sides of the equation. And what happens is this negative 75, positive 75 cancel out, leaving me just with an f of x on the left. And now we have this negative 1 that we factored out, this x minus 5 squared from factoring that trinomial, and then we're adding the 75 to it now. And this now is the answer. This is the original standard form quadratic changed to its vertex form. Both of those, if you graphed them, would give you the exact same parabola. Gives you the exact same x-intercepts, the exact same y-intercepts. It's just changed to a different form. And that's all we did. We just did a sequence of algebraic processes and a little bit of magic number math, and you just kind of have to memorize that you take that negative 10 divided by 2 and square it. Whatever that number is, divided by 2 and square it. And that creates this magic number that fills in these blanks that we've inserted on both sides of the equation. Then just some standard factoring from algebra class. And then again, back to algebraic manipulation to get the 75 to the other side. And now we have this quadratic is in vertex form. And you might wonder why did we care? Why do we want it to be in vertex form? It just depends on what you're trying to do. Sometimes vertex form is easier to graph. So if you're trying to graph this without a graphing calculator or some kind of graphing tool, well, vertex form is going to be a lot more useful. It's easier. It'll answer certain physics questions a lot easier than working in standard form. There's just, later on I'll show you a video about how to use it for conic sections, which are just another version of not functions, but there are other graphs that you have to know how to work with, and completing this work can be really useful for that. So I hope you understand a little bit more about this. Like I said, there are some things in here like solving equations and factoring and simplifying that you can find more details on other videos that I've made. But this is just putting all those pieces together to change a quadratic equation from standard form to vertex form.